project will be called cut, let's say cut 1 revision, and the programming language is C. And where do we have it? I think we can just create it at the default location. So this is our main program, and we can just clear everything up. And now look at this programming cut, and as you can see, the first question was asking you to design an awarding system, or you design a grading criteria that you can use to grade the students based on different dominations or marks or different ranges that the student can get. And we have 70 to 100, 50 to 59, 40 to 49, and all of that. And what you're required to do is, out of this, you're supposed to name some things or answer the following 4 questions. And yeah, let's see how we can go about this. And the first question says that you design a pseudocode that can be used to grade the student and print the student marks with the grading criteria that has been given over here. And how we can do that is, first of all, to ask ourselves what is a pseudocode. And to answer what is a pseudocode, we can just think of pseudocode as not actual code. Okay, even if there is a word like code, it doesn't mean that this is actual code. That's not the case. So we'll write our programs with comments, and we said we have 2 different types of comments. And these 2 different types of comments, we have the number A, I think I can call it A. We have the inline comment. This is like the one I'm using right now, is what we call an inline comment. It's represented by 2 forward slashes like that. And then the next one we have is what we call a multiline comment. And a multiline comment normally starts like that, and then it goes, and this is the start and this is the end. For you to open a multiline comment, you start like this and then you end like this. And now what this comment does, it can span to multiple lines. So all these lines are commented, and the essence of comments is to explain something, or for the human reader. Comments. So this second one, this is what we call a multiline comment, because it can span to multiple lines. And the essence of comments is to give more context to the code, and also comments can be used to do what? They can be used to disable some part of the code. Comments can also be used to disable some part of the code. If you don't want a code to function, you can just comment it out. And they give explanation to one who is reading the code. So these are the 2 different types of comments that we have. And now for this, when we're discussing this, it's best that we use multiline comments, because you don't need to be writing these 2 forward slashes every time. So we can just use multiline comments. And now the first thing is to design a pseudocode. Pseudocode to do what? To grade and print the students' marks. To grade and print the students' marks. And how we define a pseudocode is that a pseudocode, it doesn't represent the actual code. These are English-like statements that could explain, or it's not could, that explain how a program is supposed to flow, or the logic. And one of the attributes of a pseudocode is that it is language independent, in that a pseudocode can be implemented in any programming language. And so let's give an example of a simple pseudocode. Simple pseudocode example. And by this we can have a pseudocode to maybe add two numbers input by the user. So this is just a very simple definition of a pseudocode. And the first thing that we would need to have is we start. So for pseudocode, you first have to start. So the first step is normally to start. That will mark the beginning of your program. Marks the beginning of the program. After you start, you read the first number, and you can have these as capital. So you say read the first number, and after you read the first number, you can do like this. You say read the second number, and then after reading the second number, you can perform an addition. So add first number to the second number. So this is the next step. That's the fourth step. And then display the addition total. Okay, display the addition total. And after you display, you have finished the program and you stop. So now this is what we call a pseudocode. It doesn't represent the actual code. So this is the pseudocode. So the first thing, you start, and then you read the first number, and then you read the second number, and then you add the first number to the second number, and then you stop. And if you were to implement this in code, it's just simple. You just write your normal C program. So you say hash include stdio.h, and then you go to your main method, int main. So here is where, in the int main, think of it as where the program starts. So this is where the program starts. So main marks the entry point, or the start of a C. Let me just write it as capital. C program. Of C program. I don't want it to span program. It's the main is the entry point or start of a C program. So just know that the start can be defined by main. And the second thing of our pseudocode is to read the first number. And to read the first number, we said we normally use scanf. And to do that, we can do something like we first tell the user to enter the first number. So we say printf, then you tell the user enter the first number. Then you can go to the next line and do that. And now to store this first number, we have to have somewhere where we can store the first number. And to store the first number, we'll say maybe something like int first number underscore number. We say that in C you can never have spaces. So we'll actually look at these things because there's a question that is asking you to define the identifiers in C. These are some of the identifiers, these words that you write for yourselves, the functions, all those things. We'll see how we can do about that. And to now read the first number, we use scanf. Scanf, and if there's a question, you can actually ask, or if anyone can't see my screen, they can actually say that. So if there's any, if there's any question, you can actually say, and I'm sorry about that. Was my, I think I had shared, or did it, were you seeing when I was starting to type? Were you seeing the code? I hope you are seeing the what you are talking about. But the good thing is I've recorded everything on my end, so there's no worries about that. So I hope that, were you seeing my screen? I don't know whether it, oh my world, I've also seen that. So hi guys, I think I was talking to myself, but the good thing is that I have recorded everything. So don't worry. So can you all see my screen now? I think I had asked that question when we were starting. So can you all see my screen? Eric, thanks Eric. Yeah, I I had written quite a lot, and this is what I was talking about. So I think I can just go. I can just do what? I can just explain what I was talking about, and this is what I was talking about. We say that we have, I said that we have, so imagine I was typing all these and I was on mute and I wasn't sharing my screen. I hope, uh, that's just ridiculous. But the good thing is I've recorded everything, so you don't have to worry. You don't have to worry about anything. You'll get all this. And what I said as the first thing is that we have two different types of comments, and the first one is the inline comment. And an inline comment is like the one I'm using right now. And right now I mean by this comment, this is an inline comment because it's using 2 forward slashes. And I've said it's represented by 2 forward slashes. This one, these ones right here. And then we say the next type of comment is what we call a multiline comment. Multiline comment. And now for a multi-line comment, it's represented by star. It starts with a forward slash and then star, and then wherever it ends with a star and then forward slash. So you can see that all these lines have been commented out, and I wasn't forced to do things like this. So that is the beauty of a multi-line comment, and the essence of the comment is to give this is what we call the essence of comments in any program. So in any program, the essence of any comment or any comment that is written is to give more context to the code. If there was a very difficult line of code that maybe people weren't understanding, a comment can come in and be used to explain what is really happening to the code. So let me just delete this code so that we can write it again. And they give explanation to one who is reading the code. Okay, so if you just meet with a very complex code, you can have comments that can explain what is really happening. And comments can also be used to disable some part of the code. if you did not want a part of a code to execute, you can use a comment to disable that code. And yeah, that was all about comments. And then I looked at the pseudocode. And a pseudocode, I say that it doesn't represent the actual code. Even if you can see it being having the word code, it doesn't represent the actual code. These are English-like statements that explain how a program is supposed to flow, or the logic of the program, So that is a pseudocode, and it is language independent. And what does this mean? It means that a pseudocode can be implemented in any programming language. If you give someone a pseudocode, it's just a step by step. I can just say it's a step by step procedure. Okay, it's a step by step procedure to just show how a program is supposed to flow. And they are closely related to flowcharts too. But now pseudocode will actually give some of these things. It won't be a diagram. It will be just steps from one to where it stops. And I've said that a pseudocode can be implemented in any programming language. So if you gave a pseudocode to a guy that programs in C++ and another guy that programs in JavaScript, they will be able to write that program and do what is required to do regardless of the programming language. So that is the good thing about a pseudocode. And I said to start off with a simple example, I can have a pseudocode that can add two numbers that are input by the user. So if a user inputs two numbers, we can have a pseudocode that can add those two numbers. And what I've said is the first thing you do you start. A pseudocode starts by you start your program, and this marks the beginning of the program. So you start, and then you read the first number, you read the second number, you can also after you read the second number, you add the first number to the second number, and then you display the addition total, and then you stop. So pseudocode has to have a start and a stop. Okay, so yeah, that is a simple pseudocode. And what I was doing is I was now implementing this pseudocode to an actual C program. And I say that to do this, you just say you write your normal C program, stdio.h, and then you do that. Include, I haven't done include, and then you write your int main. And what this main does, it actually acts as the start. So int main acts as the entry point of any C program. You can now think of it as start. Okay, you can think of it as start. And the first thing that you want to do after you start, you read the first number. Okay, so you can just write scanf, then you can scanf whatever you want. But this one would be somehow ambiguous, because it's good to tell the user what they need to do. So you need to tell the user to input the first number. So you just say printf input the first number, and then you can do /n. We say that it's good to be having a new line after every input. And after that, where do we need to store this first number? We say it's like an int, then first underscore number, and then you scanf now for the first number. And we say that here is where we write the format specifiers. Okay, the format specifier. So you say format specifiers, and now here is where we have something like, if it's an int, the format specifier for an int is %d. If it's a float, it's normally %f. If it's a double, it's normally something like %. You can use %f or %l and then f. okay, %lf, so something like a long float, because double is longer or bigger in size than a float in memory size, and it's a character. You can also say it's %c, and also for an int you can actually use something like %i. For an int you can actually use %i. I think we can try it to display using %i. There are so many different format specifiers, but these are the main ones that you're going to be using. So in this case, you're using an integer for the first number, and an integer is %d. So you write here %d. Then you close your double quotes. Outside you write comma, then and where do you want to store it? First number. Sorry about that. So now that will read first number, and then to read the second number we do the same thing. Say printf input the second number, then we can go to the next line and close that and that. Then you say int second number, and then you scanf. Second number is also an int, so %d, and then and second number, then you do that. So these will be used to ask the user to input the first and the second number. So you can see read the first number, read the second number, and then add first number to the second number. And then to add those, we need to have something like int total or sum. Int sum is equals to, or we can write it total. Total is equals to first number plus second number. So that is how we can have our addition. So add the first number to the second number, and then you display the addition total. You display the addition total. So you say printf addition total is equals to %d. Because I want it to output as addition total is equals to %d. If you input something like 10 and 10, it should output addition total is equals to 20, and then outside you write total. And that is our program, basic program to that will implement this pseudocode. So if we run our program, it should ask us for the first number, and also ask us for the to input the second number, and also display the total that is required. And the build is succeeded. And let us see our output. Where is our output? Yeah, input first number, and input first number, let's say it's a number like 653. The second number is 34, so this should be 687. So you can see that the total is actually 687. And if you wanted to write it in terms of something like 6, 5, okay, let us first see whether %i is working. So let's see whether %i will work for an int, and say something like 534. Second number will be 5, so this will be 539. Awesome. You can see that for an int you can also use %i. You can also use %i for an int. Let's see whether you can use %i to scan for an int. So this is just another thing that you might want to know. So 54 plus 64. 54 plus 64 is 118. 118, yeah. So you can see that you can also use %i for an int, but mostly you'll find it's %d that is used in most cases. And yeah, that's it. That's how you can output. And if we wanted to display something like 545 plus 54 is equals to 599. Let's say you wanted to display something like this as the output. So you just come and write another printf here. You can say printf. There was someone who wrote for us something like this, and they wrote %d, then you write space plus %d, and then is equals to %d, and then you follow them how they are following. So the first one is first number, and then second number, and then total. And what this does is that it will take this %d and substitute it with first number. It will take the second %d and substitute it with the second number, what you've input for the second number, and it will take the third %d and substitute it with the total. And if we run our program, it will actually say that the total is, so there's something that I have forgotten to do. So it's good to always end with a new line, and I can even have them as 2 lines so that they can be a good spacing. And now if I input the first number is 43, then I input the second number is 45, this will be 88, and it should display 43 plus 45 is equals to 88. You can see addition total is 88 because here we're just displaying the total. And then here we are displaying everything. So 43 plus 45 is equals to 88. So that is how you can write a simple algorithm or a simple pseudocode to implement that. And now what we need to do is now write this pseudocode. So you design a pseudocode of the above. So it will be actually simple to do that. And then let's see if there is any question or something. So I think that we are good. If you have any questions, just you can just shoot them at the chat. If you have any question, just shoot them at the chat, and I'll make sure that I cover them. And yeah, so let's implement a pseudocode. The pseudocode, how we can design this pseudocode is just simple. And pseudocode to grade and print student marks to grade and print students marks based on this system. And the system is 70 to 100, blah blah blah, first class with distinction. And what you need to do is you just start. So the first thing is you start, and then you can, number 2, read marks input. You read the marks that have been input. Number 3, ensure you can have a third step, though this one is optional. You can ensure mark is legal. You can say ensure mark is legal or is within range. And then number 4, now here is where you determine the grade of the mark. So you say if mark is greater than or equals to, if the mark is greater than or equals to 70, you can say that you print what? First class with distinction. First class with distinction. And now this is where another question comes in. Because we are testing for multiple conditions, here is where we need to use something that can be able to test for multiple conditions. And to make multiple decisions in which there are decisions that are more than 2, we say that we cannot use just an if statement. We need to use an else if statement, because else if will allow us to input multiple conditions. Okay, it will allow us to input multiple conditions. So we need to use an else if. We can use an else if or a switch condition. Yeah, we can actually even use a switch if you needed to do that, but in this case we can use an else if. You say else if the mark is greater than or equals to 60. This is what do we give the student here? If the mark is greater than or equals to 60, we print first class. We print first class. And else if space, else if the mark is greater than or equals to 50, we print distinction. Okay, you can print distinction. And if it's greater than or equals to 40, else if mark is greater than or equals to 40, we can print pass. And anything else, so you can have it as else, or you just say else if mark is greater than or equals to 0, you can print what is it? Fail. Yeah, it's fail. So you can print fail. And after doing that, our fifth step is to stop. So this is a simple pseudocode to do that. And how we can implement this is that we can get rid of this program. I hope you've understood what we've done there. And now start with the first thing. So we start, and we say that start is normally marked by the main because it acts as an entry point. And the first thing that we need to is to read in the mark. So you just say, you can tell the user to input the mark. So you just say printf, please input the marks. And you can go to the next line as required, and then say int marks, and then scanf, you scan for the marks %d, and then and marks. So what we are doing here is we are translating the above pseudocode into a C program. We have written the pseudocode right over here, and what we need to do is to translate it into a C program, and that is what we are actually doing here. After we scan for the marks, we can ensure that the marks is valid. And how we can ensure that the mark is valid? We can do this in different ways. We can have a loop that will cycle infinitely as long as the mark is not valid. And to do a loop, something you need to understand is that we represent something as true in C is normally represented as 1, and false is normally represented as 0. So what you can do is have to ensure that the marks input above are within range. You can have a loop that can trap the user infinitely until they input a valid mark that is within range. So this is how you can ensure, but mind you, this is just an optional step. You don't have to do this. Actually, we don't have to do that. We can do that later. After we have input the marks, so we can go straight to here. Then you'll see where the problem is. So we can say if the mark is greater than or equals to 70, we can say if the marks is greater than or equals to 70, we print. So if marks is greater than or equals to 70, we print first class. So you say printf first class award. I can say award is equals to, award is first class with with distinction. Then we go to the next line and do that. And then else, if max is greater than or equals to 60, you say that printf a word is, then first class, and then you go to the next line, and then we can go to else if max is greater than or equals to 50. You say printf a word is distinction, and then go to the next line, and after that we go to 40. Else if max is greater than or equals to 40, we say printf a word is what? Pass. I think it was pass. Then we can go to the next line and do that, and then else if you can have this as max, else if the max is greater than or equals to 0, you say printf a word is fail, and you can go to the next line. So by doing this, we've actually implemented our pseudocode to a C program. So this is just all that was required. And here, for the else if max is greater than 0, you don't even have to write this. You can write it as an else part, because anything else, it means that it will be less than 40. And we award that with the fail. So if we run our program, and we can input a mark like 51, and 51 we expect it to be a distinction, and you can see that the award is a distinction. If we input another mark like 71, that is a first class with distinction, and you can see that the award is first class with a distinction. So that is because we have used an else if. If we were to use just an if statement, see how it will work. Because you can actually do something like this. If it would print just see how it would work. If we input something like 70 and we have used just an if statement, it would actually print all this. If we said a mark like 61, it will come and test out, is 71 greater than 70? True. Our word is first class with distinction. And then it will come to the next condition and test out, is 71 greater than 60? Yes. And then it will print out our word is first class. It will actually print out everything here. Okay? It will print out everything except our word is fail. Just take a look, and then I'll tell you why it's doing that. If I input a mark like 71, it will actually output everything except the last one. As you can see, our word is first class with distinction, our word is first class, our word is distinction, our word is pass, because it's testing out for all these conditions. But when we use else if, what else if does is that if it finds anyone that is true, so if it comes here and finds that the first one is true, it won't continue at all. It will just stop there, and then the program will end, or it will stop there and then skip to whatever you've written down here. So that is how an else if statement works. So now if I input a mark like the same 71, it won't do that again. It will actually do what is required, and it says our word is first class with distinction. So that is how an else if statement works. And the same thing is that you can even apply the upper bounds. If you wanted to give the upper bound of maybe 70, if the mark is greater than 70 and less than 100, you can do that and say if the mark is greater than 70 and max is less than or equals to 100. You can also give the upper bounds if you wanted, less than or equals to 69, 50, and max less than or equals to 59, and max less than or equals to 49. I think those are the upper bounds here. So if max is blah blah blah, and also the last one you can say else if max is greater than or equals to 0 and max is less than or equals to and equals to 39. So it's from 0 to 39. So you can specify the upper bounds if you wanted to, but the greater than always work even without the upper bounds. But now the problem comes in here. The problem would come in here if you input a mark that is not valid, okay? Because we can input a mark like 112. As you can see, nothing is actually being outputted. 112. So what you need to do is that, and the reason why nothing is being outputted is because you have added this upper limit. And we have said that the mark should also be less than 100. So all these conditions will be false, and so nothing will be printed. But to counter that, to ensure that we can have an infinite while loop. So we can have a loop, and we said to create an infinite while loop, you say while 1, okay? While 1. So this represents an infinite while loop. So it will loop infinitely until it's broken. To break so to stop an infinite loop, you use break. Use the keyword break. And that is what we'll do. So what was required of you to answer into a C program is just this. Okay, you don't even have to do all these with the while loop and all. This is just optional. So you can say while 1, and then you say if the max that has been input is if the mark is less than 0, okay, because they can input a negative number, if it's less than 0 or max is greater than 100. So you can see that we are using OR. Okay, we are using OR because if it's less than 0 or greater than 100, what do we need to do? You tell the user printf and tell the user invalid mark input again. Invalid mark input again. So you tell them to input again because that mark is not within the range that is required. And then you say the same thing, scanf, and then %d, and then and marks. And after the input, then you say else. You can print the mark is valid. So you can say printf mark is valid. So this will just ensure that the mark is valid. And after a mark is valid, now you need to break out of the loop. And what have we said? If you need to break out, you use the keyword break. So you just say break. And now this is what will trap the user infinitely up until they input a mark that is the required mark. So if I run my program again and now try to input 112 for a mark that is not valid, you can see that it's telling me invalid mark, input again, invalid mark, input again, invalid mark, input again. Even if I try to input a negative value, it's also an invalid mark, input again, -7, invalid mark, input again. So this will loop forever up until the day I input something like 64, which is a valid mark. So you can see after I've input 64, it's saying the mark is valid and the award is first class. Okay, so that is how you can do that. And one of the last things I want us to do is we can also change this into a switch statement. You can change the above into a switch statement. And how can we do that? You just say switch. Let me just write it manually. So you say switch, and then what do you want to switch? The marks, okay? The marks. And then switch normally has different cases. So the first case will be case, where is it starting? So case 72. So here we normally use 3 dots to represent a range. So if we are going from 70 to 100, we use those 3 dots. And then you can say break. So down here is where, inside the case is where you normally print. So you say print, printf. I think we can copy whatever we had here, or we can just type printf and then say a word. So for the switch statement, we can say a word in switch. A word. How can I call it? Switch a word. So like it's just to tell us that we are reading from the switch statement. Switch a word is first class with distinction. Then we can go to the next line and do the same thing for all of them. So you say case 60, 1, 2, 3 to 69, and then you break. So remember that for a switch statement, you always have to have the break statement. So switch a word is first class, and then go to the next line and then do that and break, and then case 50 to 59, then you break, and then you printf. So I need to have 3 dots, and then you printf and say switch a word is distinction. Then we go to the next line and that. Then the other case is case 40, 1, 2, 3 to 49, okay? To 40, 50, 40 to 49, not 50. Break, so this is 40, and then you printf switch a word is what? Pass. And the last thing, a unique thing about the switch is that it contains the default case. Think of it as the else part, the else that does not have an if. So the else part. So the else part of a switch statement is what you call the default case. So in this case, you can say case 0 to what? To 39. You can say, you can break and then say printf switch a word is fail. But for this, you can actually replace these 0 to 39 with the default case. So you just say default instead of doing that. You can say default case. So this will be anything else, because if all these haven't been satisfied, that means this last option is the one that will be satisfied. So let's see how it will be. So it would be displaying the award for if, which is award is blah blah blah, and then it should display for the switch case still. So if I input a mark like 500, you can see that it's an invalid mark. 300 invalid, -3 invalid, but 60 or 50 is a what? 50 is a distinction, so it should output award is distinction, okay, and then it will also output switch award distinction. So let's see. You can see that it's saying award is distinction, And then switch a word is also distinction. So this is how you can implement that that program using a switch statement and also an else if statement. An else if statement. That is how you can go about it. And this is how you can trap the user up until they input something that is that is that is what that is valid or is termed as a valid mark. And that is how we can translate it into a C program. Outline the advantages of using a pseudocode compared to a flowchart. I think that is the theoretical. So I want to do the last one, which is a program. So using a program to add two numbers. Actually, we wrote this program as the first program. I did not recall it was even here. Explain the structure of a C program. So up to there, do we have any question? So I think we can do that as the last thing. Does the program run without return 0? So if you don't write return 0, by default, it will actually add itself. It will actually add itself, because when I run it, I think it will say that program ended with return code 0. So exactly, so you can see program ended with exit code 0. It automatically does what? It automatically just inserts itself. So you don't have to do it, but for an exam purposes, you have to have the return 0. But if you're using an IDE like this, it will automatically add it for you if you haven't. But if you did not want to use it at all, you can convert this int main into void main. So it says a void main instead of an int main, and that should still work perfectly. So if I input my marks as something like 54, you can see it's still executing, and it's saying exit code 27 and all. So these are, it doesn't matter, but just know you can also use void main if you did not want to use int main. But in most cases, it's int main, and you can see that it's giving us a warning. Return type of main is not int. Change return type to int. So it's telling me that it needs an int. So yeah, that is how you can do, and you say return 0. And that is it. And the last thing that we want to do is just to add two numbers as we explain the structure of a C program. So any question up to there? And for those who can't see my screen, I think it's normally a problem of logging back in and out again. So I think the others can see my program. So just a minute. I do this. So let me just send a USSD for my thing. Okay, send. So that is it. If you have a question, but the last thing is just to explain, and what we mean by the components of a C program, or the structure of a C program, is what makes up the C program. Okay, so you just write in terms of what does the C program entail, and in this case we have the preprocessor directives and preprocessor directives, and these are the ones that are used to import the required libraries into our C program. Like in this case, we needed a library to input and output. So to output, we need the stdio library, and to input, we need also the stdio library, and to output, we normally use printf. To input, we normally use scanf. Those are some of the different features of a C program. And also we have the We have comments, things that we are actually using right here. Comments and all those things. The comments. We also have the functions. We have the function prototypes. All those things are the ones that entail or make up the C programs. And we have the identifiers. We'll see actually some of the rules for our identifiers. So those are the things that we need to just discuss. It's something very simple. So what we need to do is just to write a program that can add two numbers. And for a program that can add two numbers, we don't even have to scan. Okay, we don't even have to scan the number. So what we'll do is just declare our variables. Just to declare our variables, and then they can be added manually. So I can just close that, and if you can't see my screen, you can just log back in. And the last thing that we just need to cover is that program, as we explain some of the different features of a C program. And so let me just get rid of this infinite mirror. How is the question calling them? Structure of a C program, okay? Of a C program. So the structure of a C program, first we have these hash include stdio. So we normally have things like the preprocessor directives. And for the preprocessor directives, these are used to include required libraries to our C program. That is the use of the preprocessor directives. So some of the other things, some of the other structures of our C program, we have the comments, things like the comments. In this case, we said we have the multi-line and inline comments. We have things like functions and function prototypes. So we have all these things that can be used in our C programs. We have different identifiers such as explain the structures of a the C program. And to add two numbers, it's just something very simple. So if I wanted the program to just end, to not execute whatever is down here, I can have my return 0 over here. Okay, this is a hack you can do. If you don't want the program, anything to be executed out here, down here, you can see I have written my return 0 over here. And to just prove it, you see that I can say printf, hey, my program has just reached here. And you'll see that it will just output this thing only, because it will ignore everything else. And you can actually see that it's telling me code will never be executed because we are returning over here. So just know that in this case, if you have the main method, it ends where there is return 0. It doesn't matter whether you've written things down there. Where it will find a return 0, that is where it will end. And you can see it's only displaying, hey, my program has just ended here. So we can just write our program that that adds two numbers here, and we can say int. So we can, I think we can use floats this time. So we can say float first number, and then float second number. So we can say first number is equals to something like that, and is equals to something like that. And then we just print the total. So we say float total is equals to first number plus second number. And then we just display the total, and then say printf. Then you say the first number plus the second number, blah blah blah. So we have other attributes such as the what do we call them? In our C program, we have things such as the format specifiers, and it's what we are going to use. These are the %fs, %cs, %s, and I think we didn't say %s when we were doing here. So for the character array, we normally have string or character array, which is represented by character array, is normally like this, %s. And in here we say %f plus %f is equals to %f. This is the same thing that we did with the other numbers when we were just, here is we can say here is a float addition of two numbers. And then we say the first %f is for first number, the second %f is for the second number, and then the third one is for the total. So let's see how it will output these. Let's see how it will output this. So you can see it's outputting 45.000, 163.000, blah blah blah, 28.000. We talked about how we can format the decimal points, and we said if you want to format the decimal point, you just come before the f and say 0.1f. That means it will be just one decimal place, 0.2f. Then the total 0.0f. So this means it will just display one decimal place. This will just display two decimal places. This will display 0 decimal places. So if we run our program, you can see that the first one is actually displaying one decimal place, the second one is displaying two decimal places, and the last one is 0 decimal place, because I've said it's 0f. So if you didn't want all of them to have decimals, you say %.0f, and that is it for our C program. So these are some of the structures of our C programs, and I think we looked at others with the other classes. Structure. What was the structures? I think I will share these whatever we are doing here. I'll share with you. You can see we have statements, global variables. We have also statements. Okay. 5, we have statements. So statements, these are the ones that end with a semicolon. So whatever ends with a semicolon is what we call a statement, and it is what is actually executed by the computer. So whatever you see ending in a semicolon, we normally call it a statement. So we have statement, and also we have global, and number 6 we have global and local variables. So the global, the difference, if you ask the difference between a global and a local variable, is that a global, these variables defined outside any function, and for the local, these are variables defined inside the functions. So that is the difference between a local and a global variable. Something like float first number, these ones, they are local variables. This is a local variable because it is inside the main function. This is a local variable because it is inside the main function. But if I was to define it outside here, so I say float global, float economy, or what can I give it? So float global is equals to 1.33. So this is what we call, this is a global variable. This is a global variable because it is defined outside the main function or any other function. Okay, so those are some of the different attributes of our C program, and the 4 rules that should be followed when writing identifiers in our C program. So think of identifiers as these numbers. Identifier, it could be a variable name. Let's say identifiers in C. So this could be function names. It could be variable names. It could be constant names. All those things. And while defining these, the rules are, these are the rules. And the first rule is that you should not use white spaces to write your identifiers. What this means that is that you should never have a space when you are writing your variable. Okay? If you want to space out, just use an underscore. So just use an underscore. And also another thing is that identifiers should never start with a number. You should never start with a number. If you are naming something like your variable, if you needed to name something like a float first number, you can never write something like this: float first underscore number. I am beginning with a number. This is not legal. This is not legal. So you should never start with a number. And also another thing is that you should never use reserved keywords to name your identifiers. Identifiers. You should never use reserved keywords to name your identifiers. So some of the reserved keywords, in C include, these are keywords like float, double, int, while, for, return, void. So these are the different types of keyword, etc. There are so many. You should never name your function something like function void int, void while. You should never do that. You should never do that, like to rename. And also case sensitivity. Okay, so case sensitivity. C is a very case sensitive language, in that something like e.g. printf is illegal. It should be printf with a small p. Okay, case sensitivity. If you wrote something like while is illegal, should be while with small w. So those are some of the rules that you should ensure that you always follow. While you are doing your C programs. Okay, you can. Where we said you can never start with a number, you should never start with a number. Yeah. Here you can start with an underscore or any letter in the alphabet. Then anything else can follow when you are writing your identifier. So that is what we can do for that, and I think that is it for our program. So the difference between a compiler and an interpreter, they I have covered those, and I think you can just Google those and see. I did not want to take much of your time, but just know first of all that a compiler, I think it's just like to give two differences. First of all, a compiler, compiler and interpreter. I'll share this code, this script. So compiler takes your code and compiles it, producing a compiled file that the computer can understand or execute, that the computer or the machine code, machine. We normally call it machine code. And normally you tend to find that compiled languages are way faster than interpreted languages. So a language like C, so compiled languages include a language like C, C++, Java, C Sharp. So those are some of the common compiled languages. I think also Kotlin. So those are some of the compiled languages, and interpreted languages include languages like Python and JavaScript. So the interpreted languages are executed or interpreted line by line. So this is the major difference, okay? They interpreted line by line, but for the compiled languages, it takes your code, compiles it, and produces a compiled file that can be read by the computer. And yeah, that is it for the flowchart. What we've done this, advantages of using a pseudocode as compared to a flowchart. So a pseudocode is actually easier to execute. Flowchart, you also have to draw diagrams and all. So I think we can't draw flowchart for this. I think we'll do that in the last session as we go through Cat 2. Yeah, so I think that is it. Anyone with a question about that, or a question on anything, or anyone who hasn't understood anything? So I'll share this script. So let me just even save it. You'll receive it with your class rep, and I'll also upload. I think I'll upload this video because we have covered quite a lot. Okay, so yeah, I think that's it for the session today. If there are no questions, we can end it at that, and we shall meet for the last session. Yeah, okay, and look at what is required. Okay. Thank you, everyone. I'll share everything with you today, and also the video will be made available for all of you if you want to just look into it. So that is it. Enjoy your evening. We'll meet next time. Thanks, you all.